directly intervene, okay? So it's time to start. So welcome everyone. This session is titled Software Security 2, and we will have a mix of journal first papers and technical track papers. So welcome. So let's start. So we will have presentation first, and then we will have question and answer later. So if you want to ask question for any of the speaker, please feel free to post your question on the chat and provide the details of the person or the paper to which the question is directed. So let's start with the first paper. The first paper is a journal first paper, and this titles Lags in the Release, Adoption and Propagation of NPM Vulnerability Fixes. The speaker is Bodin from Nara Institute of Science and Technology. Please, Bodin, the floor is yours.
Okay, thank you, and hello everyone. My name is Bodin Chitanet from Nara Institute of Science and Technology, Japan. I will present our journal first paper entitled Lags in the Release, Adoption and Propagation of NPM Vulnerability Fixes. So as you may know, security is a growing concern. First, and the risk it poses is not only affect to the direct clients, but is also cascades transitively across the software ecosystem. To mitigate the risk from the vulnerability, developers need to adopt a vulnerability fixes quickly. However, only frameworks specifically looking at the vulnerability fix and its lag during the propagation across ecosystem. So in this study, we do an empirical analysis to identify and characterize lags in the vulnerability fixing process. So we use libraries and vulnerabilities from NPM, which is one of the biggest package ecosystem in the world. So here I will briefly explain about our analysis and the results. First, when developers know that their package is vulnerable, they have to work on fixing a vulnerability, and then they have to make a fixing commit. And later on, they have to release it as a fixing release, which in this case is a new version called version 1.1.1. And here we suspect that during the fixing process, there is a potential lag. So we manually investigate those fixes at the commit level and line level. And the result, we found that the fixing release usually bundle with unrelated commits, which among those commits, there are just only few lines of code that actually related to the vulnerability fix. Let's move to the next level, which is the direct client of a vulnerable package. As you can see here, that the package A released a patch to fix a vulnerability. So after that, when we considering at the client side, there is a potential lag that there is the potential lags in the fix adoption, as developers have to adopt a bigger changes because here they didn't update their dependencies, so they have to make a bigger changes, which is in this case is a minor change. So in this study, we investigate this kind of lags in the fix adoption from the version changes, and we found that patches from packages are usually adopted as a minor landing by clients, which means that clients keep outdated dependency, so they have to spend more migration effort due to the potential risk from backward incompatible changes. And then let's move to the another level, which is a transitive client. So in this case, a client C cannot adopt the vulnerability fix directly and are forced to wait for other packages in their library supply chain to adopt the fix first. So here we suspect that there are some kind of factors that might influence this kind of lags. So here we look at two factors, which is severity of vulnerability and lineage freshness, which refer to version branches that the fix was released. And we found that those factors influence lags with the latest lineage and medium severity suffer the most. And here is this lesson that we learned. First, the release cycle matters. There is a need for strategy to make the efficient update to reduce lags. Second, migration cost effort. If developer keep outdated libraries, it might increase chance of backward incompatible change. So we suggest that developers should frequently update their libraries. And third, the awareness of physics is important to allow quicker planning of update. Even though downstream clients cannot directly adopt the fix from library, however, they could prepare themselves so the lags from migration is minimum. Yeah, that's all from my presentation. So please feel free to check our replication package and the full papers as shown in the QR link. Thank you.
Thank you, Bodin. Thank you very much. Now it's time for the second speaker. The second speaker is presenting a journal first paper, which is titled The Case for Adaptive Security Interventions. The speaker is Ayrum Rauf from the Open University. Please, Ayrum.
Can you hear me? Hello? Hello?
We can hear you, Ayrum.
I can hear you
very well and can see your presentation.
Perfect. Thank you. So I shall start then. Okay. So hello, I'm Ayrum Rauf and I'm postdoctoral researcher here at the Open University in UK. And I'm here to present you our paper today. That is a journal first paper. The paper is co-authored with my research team that comprises of software engineers, security specialists, and cognitive and social psychologists. So in this 5-minute talk, I will briefly introduce you to our paper that is titled The Case for Adaptive Security Interventions. The main message of this paper is to encourage software security researchers to think of security interventions as socio-technical systems that need to be designed with sensitivity to developers' cognitive load and social contexts. So in this context, we refer to security interventions as those actions and events that occur during the code development process in order to promote developers' security behavior. We suggest and operationalize adaptive security interventions that are responsive to developers' needs. In order to understand the influence of developers' socio-technical context on their security behavior and to know what impedes them to meet their security goals, our first research question asks, how can cognitive and social psychology explain the impediments to developers' efforts to meet security goals? Our high-level literature review of psychology literature related to behavioral goals, which is reported in this paper, suggests knowledge, attention, and intention as important determinants to achieving behavioral goals in the individuals. We did literature review of developer-centered security as well and identified these psychological elements also impede developers' to write secure code. Knowledge deficit is when a developer loses focus. Knowledge deficit is when developers use outdated knowledge, and attention deficit is when developer loses focus on security when he's working on functional features of the code, and intention deficit occurs when developer as consider security as someone else's responsibility, or the product owner does not consider security as a priority. Then our second research question investigates how we can design interventions to help developers reduce the obstacles in operationalizing security goals. Based on our study of security interventions and their analysis, we developed an understanding that not all types of security interventions suit every need of the developer. So we suggest adaptive security interventions. We operationalize adaptive security interventions using MAPE loop, which is commonly known as adaptation loop. And we go through the activities of monitoring, planning, monitoring, analysis, planning, and execution over a knowledge base to vary the response of a system following changes in the operational environment. We make this operationalization concrete with an example and a tool for demonstration purposes. We present the case that adaptive security interventions should address the security need of developers by monitoring their coding behavior and delivering appropriate security interventions for their needs. The aims of our adaptation is to diversify the channels by which security interventions are delivered. So not just via IDs, but also via other communication and collaboration tools. These interventions are delayed. That is, the timings of the interventions are varied and not just instantly inside IDEs. Psychologists suggest that delaying the intervention can trigger long-term behavior change by encouraging their users' information recall and avoiding the negative effect of frequent interruptions. We also escalate the interventions when some are not effective by not just delivering to the developer, but also involving the wider social context, such as a development team and other stakeholders, and making it a collective responsibility. Moreover, our interventions are a learning process in itself that accumulates knowledge after each iteration and thus can improve over time. Our research opens many research challenges, and we invite software engineering and security community to investigate such high-level interventions. To conclude, this work highlights the need for new thinking to support a continuum of developers who are coming from various backgrounds and various skills. The case for adaptive security intervention that we present in this work outlines such a possibility, and I thank you for your time, and I look forward to hearing your feedback during the discussion. Thank you.
Thank you very much, Irun.
Thank you.
So if you have questions for Irun, please chat. The next speaker is also presenting a journal first paper. The paper is titled Out of Sight, Out of Mind, How Vulnerable Dependencies Affect Open Source Project, and the speaker is Shar from Singapore Management University. Please.
Anna? Okay, so I'm here to talk about our journal first paper called Out of Sight, Out of Mind, How Vulnerable Dependencies Affect Open Source Projects. And my name is Shah, I'm the third author. So as we all know nowadays, open source libraries are widely used in many software projects. And turns out that those libraries also often contain security vulnerabilities. And as the usage of libraries grows, libraries being dependent on several other libraries transitively, security analysis tasks of those libraries become very complex. And also, a study by Kula et al. In 2018 also shows that developers often do not review the security of third-party libraries. As a result, dependency vulnerabilities, that is, vulnerabilities in directly used libraries or transitive libraries, may be missed. So this motivates us to analyze prevalence, types, severity, and persistence of dependency vulnerabilities in software projects, along with the relationships between project attributes such as popularity, complexity, size, and dependency vulnerability counts. So we want to answer questions like, what are the security risks library users should be aware of with respect to the use of dependencies? Is it sufficient for a library developer to fix vulnerabilities in their library and release a new version as soon as possible? How effectively can we reduce the security risk in software projects when we are using the So to answer those questions, we selected a REPA dataset from Munaria et al., which is published in MC 2017, which contains about 1 million software projects from GitHub repository. And among them, we randomly sampled 450 actively maintained projects written in 3 popular programming languages, Java, Python, and Ruby. So it means 150 projects for each language. And we checked out each commit made between 2017 to 2018 for a 1-year period. And we perform a full security scan using a software composition analysis tool, which is Veracode. That is a commercial tool which generates software dependency graph of a given project. And it will analyze the graph to identify direct and transitive libraries used in the software project. And it will report CV vulnerabilities that is in the public database, as well as the vulnerabilities that are not yet listed. So these are the 2 main research questions that we were trying to investigate. What are the prevalence and common types of dependency vulnerabilities in open source software and their persistence? Also, we look at what are the relationships between vulnerabilities in the project open source dependencies with respect to the attributes of the project and its commit. So here are some of the important results and findings. Well, to answer how prevalent dependency vulnerability, the short answer is yes, very much so. For example, if you look at Java, an average across 150 projects that we looked at, 12.3% of the dependencies contain vulnerabilities, which is quite alarming, I guess. Common types of vulnerabilities are denial of service and information disclosure, which are common across the 3 languages, which means that improvement of practices or tools to combat these 2 types of vulnerabilities should be considered. Another interesting aspect that we looked at is about the non-CV dependency vulnerabilities, because we want to know whether it would be enough for the developers to just monitor the CV updates and patch vulnerabilities that are reported in CV only. Well, the answer is that we found that a good percentage of non-CV vulnerabilities are present, especially for Java and Ruby projects. So it means that developers could still miss these project dependencies, even if they do actively monitor the CV updates. Of vulnerable libraries is not updated to non-vulnerable version, even though there is availability of the patch, meaning even though the library developer has already produce a fix for it, developers, do they update often, which is discussed by the first presenter here. So yeah, we find that especially for Java projects, on average, for Ruby project, 36.7% libraries were not fixed, even though there is a patch available. And last thing that I want to talk about is the correlation between different types of project attributes and the dependency vulnerabilities, so that we can evaluate how we can reduce the security risk. Well, to answer it shortly, most of the project attributes that we look at, for example, project age, number of commits, number of priority, doesn't really matter. So what matters is also trivially the number of direct and transitive dependency statistically significant effects based on the regression model that we have here. So it means that to manage the dependencies could be more effective, managing the dependency would be more effective at reducing the risk rather than increasing the number of developers or whatnot. So that will summarize the finding, and I'll be looking forward to the Q&A session later on. Thank you very much.
Thank you very much, Shar. Please post your question to Shar on the chat. And the next speaker is presenting a paper accepted in the technical track. The paper is titled MVD, Memory-Related Vulnerability Detection, based on flow-sensitive graph neural network. And the speaker is Si-Tong from Yangzhou University.
Okay, thanks for your inviting. Hello, everyone. My name is Cong Cao. I'm a PhD candidate in Yangzhou University. It's my honor to share our latest work, MVD, Memory-Related Vulnerability Detection based on flow-sensitive graph neural networks. Memory-related vulnerabilities can result in performance degradation and program crash, severely threatening the security of modern software. As reported in CWE Top 25 Vulnerabilities in 2021, 2 of top 3 vulnerabilities are related to improper memory operations. Despite the effectiveness of static analysis-based approaches, well-defined vulnerabilities patterns are highly dependent on expert rules or patterns and difficult to cover all the cases. What's worse, the complex programming logic in real-world software projects gets in the way of the manual identification of the rules. Recently, benefiting from the powerful performance of deep learning, a number of approaches have been proposed to use deep learning models to extract implicit vulnerability patterns from vulnerable code. However, existing deep learning-based approaches suffer from 2 limitations. The first is flow information under-utilization. Due to the lack of inter-procedural analysis, most of deep learning-based approaches may fail to mine precise program semantics. However, in real-world programs, operations like calling a user-defined function which realizes memory allocation of free are widespread. The second problem is partial flow information loss in model training. Limited by the capability of popular deep learning models in handling multiple relations, partial flow information is lost during the process of model training. Another limitation is close granularity. The detection granularity of the existing deep learning-based approaches is mostly at the function level or slice level. However, developers still need to spend a deal of time in manually narrowing down the range of suspicious statements or operations. Therefore, we can find that comprehensive and precise interprocedural flow analysis is necessary because it can make our detection model learn more precise code semantics. In addition, sensitive contextual information within flows helps to refine detection granularity. The workflow of our approach, MVD, is shown as follows. To train the detection model, MVD first extends the program dependence graph with additional semantic information, like correlations and return values obtained from code graph to conduct interprocedural analysis. Furthermore, to reduce irrelevant semantic noise, MVD conducts program slicing from the program points of interest. In step 2, MVD uses doc2vec to transform the statements of each slice into low-dimensional vector representations. In step 3, MVD uses flow-sensitive graph neural networks to jointly embed nodes and relations to learn implicit vulnerability patterns and rebalance node levels distribution. For the detection phase, we repeat step 1 and step 2 and use a well-trained model for detection. Okay, we focus on step 3, graph learning part. To train a model which can learn implicit vulnerability patterns from source code and identify suspicious vulnerable statements, we construct a novel graph learning framework, flow-sensitive graph neural network, FSGN, for graph learning. In the graph embedding phase, we leverage the entity relation computation operations to jointly embed statement nodes and multiple flow edges to incorporate edge embedding into the update of node information. Then we adopt weighted inner production to generate edges and gives link predictions for sensitive nodes by setting a threshold to keep the connectivity of the graph. If the predicted probability of connection between sensitive node and its closest neighbor node is greater than theta, both the sensitive node and corresponding edge will be put into the augmented matrix of original graphs. Finally, to train the detection model, we use the softmax activation function as the last linear layer for node classification. We raised 4 research questions and manually constructed a new vulnerability dataset, which contains 4,353 vulnerable samples, covering 13 common memory-related vulnerabilities for evaluation. For RQ1 and RQ2, MVD achieves better results and outperforms all of the 3 referred deep learning-based approaches and static analysis-based approaches. Moreover, in terms of all metrics, MVD can improve the best performed baseline divine by 5% to 12%. In RQ3, we conduct an application study by replacing our FSGN with other state-of-the-art GN frameworks. We observed that FSGN can improve the best performed baseline RGC by 6.7% and 14%. In RQ4, we account for the time cost in seconds of each approach in training and detecting vulnerabilities. In spite of a great deal of training time, MVD achieves relatively shorter detection time with better detection results, making a trade-off between accuracy and efficiency. Okay, this is all of our work. We propose a new approach for detecting memory-related vulnerabilities, and we release a new dataset, and we conduct a comprehensive experiments for evaluation. That's all my presentation. Thanks for your listening.
Thank you very much. Let's thank the speaker again. It's now time for the fifth paper. This paper was also accepted at the technical track, and the title of the paper is VulCNN, an image-inspired scalable vulnerability detection system. I'm not sure if the speaker is in the room. Seems the speaker is not in the room. Are you the speaker of the fifth paper?
Yeah, sorry, I have the connection problem to my microphone.
We can hear you now.
Okay, thanks. And can I see the screen?
Yes, please.
Okay. Cool. Hello, everyone. It's my honor to present our paper here. My name is Duo Xu. I'm now a master's student at EPFL, and I participated in this project during my time in Huazhou University of Science and Technology. Now I start to present our project about VulCNN, an image-inspired scalable vulnerability detection system. First is our motivation. Since deep learning can automatically learn features from source code, many projects have been proposed to apply it to detect source code vulnerability. Those projects can be classified into 4 main categories: the token-based, slice-based, tree-based, and the graph-based methods. Among these approaches, graph-based methods can achieve better detection performance since they can maintain the program semantics of source code. However, they cannot scale to big code due to the heavy time consumption of graph analysis. Therefore, we raise a research question: how to make graph-based methods complete large-scale vulnerability scanning. Inspired by the existing deep learning-based image classification technique, which can analyze millions of images accurately, we plan to use those techniques to accomplish our purpose. The challenge is how to efficiently convert the source code of a function into an image while preserving the program details. To address the challenge, we introduce social network centrality analysis into deep learning-based vulnerability detection. A function can consist of multiple lines of code, which together implement the program semantics. However, the importance of code lines may differ. For example, some code is just a simple variable definition, while some code implements the core algorithm of the function. To better preserve program semantics, we need to figure out how to find out the contribution of different lines of code in the function to the program semantics. We illustrate the example code in program dependency graph. We then use the adjacency matrix to present the PDG. The code lines degrees are illustrated in the right figure, which are obviously variant. This is because of different relationships between the different code lines. We can utilize this to represent program details. In practice, the degree of a node in graph is originally used to quantify its importance, which in this case may represent the importance of a line of code. Therefore, we design valCNN by analyzing the importance of all code lines. Next, I'll talk about our system design. valCNN consists of 4 main phases: graph extraction, sentence embedding, image generation, and finally, we will use a trained CNN for classification to see if a given program is vulnerable or not. Centrality concepts were first developed in social network analysis, which quantify the importance of a node in the network. Here we utilize the 3 centrality measures: degree, closeness, and CATS centrality. Inspired by the RGB channels of the image, we use the 3 centralities at the 3 channels to represent programs. Through this, we can achieve a more complete representation of the importance of code lines in function program semantics. After embedding all the code lines to vectors, we perform centrality analysis on all nodes in the new PDG to collect their centralities. We then multiply the vectors by the corresponding centrality to construct 3 channels, and finally form an image. The last part is our evaluation. About our test dataset, we first collect a dataset from SARD and another from the NVD. For real-world non-vulnerable functions, we randomly select a part of the dataset in a recent paper which has non-vulnerable functions from several open source projects. We then compare valCNN with several vulnerability detection tools. We selected 3 static analysis tools and 5 deep learning-based vulnerability detection approaches. Moreover, we also add the version of valCNN that doesn't utilize centrality into evaluation to see if the feature is really helping. Results show that valCNN outperforms these comparative systems. Finally, we perform a comprehensive evaluation on runtime overhead of valCNN. Some methods are excluded in this evaluation because they are not deep learning based and perform worse than other 5 deep learning based approaches. The figure shows that valCNN is only less as scalable as token CNN, but a lot faster than other 4 approaches. Thank you all for listening, and thank you all for asking questions.
Thank you very much, Duo. If you have questions for Duo, please post them to the chat. And now it's time for the last presentation. It's also a paper accepted at the technical track. And the title of the paper is Default Mutual Information-Based Crash Triage for Massive Crashes. I don't know if the speaker of this paper is in the room. Xing Zhang, maybe? So I'll call the paper again. So this is the last paper, Default Mutual Information-Based Crash Triage for Massive Crashes. Is the speaker for this paper in the room? Okay, so it seems we don't have a speaker for this paper. So I guess we can open the we can have questions for the speaker. So I can see at the beginning, I can see questions in the chat. So I can see there is a question for Bodin from Kushal. Kushal, do you want to unmute your microphone and ask the questions in?
Sure. I think Bodin responded to my message.
Yeah, but you can still, yes, please.
Yeah, so my question was around what your recommendations are in each of the 3 areas of improvement that you've mentioned. So you said the release cycle, the update frequency, and lack of awareness are the three things that need to be improved, right? So I just wanted your thoughts on this.
Yeah, thank you for the question. So, yeah, in my opinions, right now there's a lot of like kind of tool that that helps developers to like automatically update their dependencies, like such as Dependabot. But those kind of tool is not perfect. Like there's some times that they cannot provide a base solution, like how to update the dependencies without reviewing like some breaking change, for example. So I think there's a lot of things that we can explore in order to improve the tools that helps developers to like migrate their dependencies.
Okay, thanks.
Thank you, Bodin. There is another question for you in the chat. This is from Fanny. So I'm not sure, Fanny, if you want to unmute your microphone and ask the question.
Yes, sure. Bodin, I am curious to know, what do you recommend inside an organization that helps the employees receive more quickly the updated packages related to software, and that considers that such vulnerability is urgent to fix? What is your views, your recommendations?
Yeah, so from my opinions, this for the strategy for the organization, I think, yeah, similar to the previous question. So right now there's some kinds of tools that helps developers to analyze both the vulnerability inside their software, and there are some also the tools that helps developer to migrate a newer version of dependency to fix the vulnerabilities. So my my suggestion is that, yeah, for organization, so it might be helpful to like adopt those kind of tools in your like operation pipeline. For example, some kind of tool can be like analyze your code when you try to like after you build your projects or before you deploy to the production. Yeah, but as we know, like the tool is not perfect. So yeah, there's sometimes they cannot actually fix our code like automatically. So yeah, the future work is that, yeah, try to like we have to try like some way to improve like of the tools. Yeah.
Thank you, Bodin. I just have a follow-up on that. I mean, one of the main problem is the bill of material. Developers find it very hard to keep track of all the dependencies and packages they are using in their projects. And so it's very hard also to decide when an update should be performed. And do you have any findings on when is the best time to do an update from your work, or is it convenient to do an update right after an update is released?
Yeah, from my experience, when I look at the data, like people tend to not update to the newer version because like the current version that people use is like it's already stable, and they don't need to like to get like some new features or or something like that, because like when people try to update their dependency, there's a chance that that those kind of changes will break their code. So, but in order to to eliminate like the risk, I think it's worth to like spend some effort to check whether the new version of the libraries is it compatible to your like source code or not. Right now I can imagine just only that like that case.
Thank you, Bodin. I guess we can move to maybe try to ask question also to the second speaker now. I see a question for Irum from Kushal. Kushal, do you want to put your microphone on and ask the question? Hello, Kushal, can you unmute your microphone?
Can you hear me now? I hope it's better now.
Yes.
Okay. Yeah, my question was just around how you would compare the adaptive security-based approaches that you're mentioning with something like a DevSecOps cycle, which also involves around changing the culture of the developers and integrating multiple steps in the way of development to detect these issues and kind of combat them.
Yes, I understand that. Yes, thank you for your question. DevSecOps is more of a collaborative approach as well, and it integrates into the whole development cycle, the security steps and security mechanism. Our work differs in the sense that we are building on the theories from behavioral sciences as well on how to improve the behavior of developers. Collaborative collaboration is one part of our work, so that is not the sole thing. Even the developers who are working, because we are talking about developers who are working outside the organization boundaries as well, so we are using different communication mechanism, not just IDs. It could be Slack even, or it could be Twitter or GitHub, and also it could be based the analysis and planning activities that are built on the knowledge base. They look at all the security interventions that are available in the knowledge base that are available for the developer to use based on what the needs are, what programming environment they're using or language they're using, and also study their coding behavior to analyze whether it's a knowledge issue the developer is facing, whether it's just that he's not attentive enough to security, and or whether it is that the stakeholders or he himself is not interested in that, or if he's working alone, he can make a case for security with other stakeholders or the owner of the product by committing it to the GitHub. So that's just one example of how we think adaptive security interventions can be operationalized and made concrete. And there's a lot to more to explore here in different types of activities. But to sum it up, it's more of it's not just a collaborative tool, it's just not about making security culture. It is about it, but not just about it. It's also about understanding the coding behavior of developer also, and using behavioral science theories to understand what the actual issue is. I hope it helps.
Yeah, got it. Thanks.
Thanks.
Thank you, Irum. Anyone else has question for Irum? Actually, I have a question for you, Irum. It's related to the intervention. I just would like to, because in this session we discussed vulnerability fixes, vulnerability detection, and I'm wondering, can you give us an example of some security intervention that you apply in your work? Practical examples of security intervention that you use in your work.
Yes. So the main feature of our work is that it's not transactional. So it's just not that there's a vulnerability and our intervention would intervene and give a suggestion that this is what you should do. It's a bit high level. It builds on existing intervention and suggests that this intervention might be suitable. For example, so we're talking. Let's take example that a developer is coding, and the tool notices there is a vulnerability, and it notifies the developer that there is a vulnerability. If the developer does not fixes it for 3 times, for example, and it is being monitored, then the tool takes notice of it and stops intervening and stops notifying again, because it's more of an interruption, and developer is more of ignoring it. So he'll take a note of it, and then maybe in the second loop it plans another strategy for it, that maybe it's an attention deficit, and then notifies him through Slack after 3 or 4 save and realize that he's not doing it. So it's more of and then again, if he does not address to it, then maybe to a wider context it send a message, and this way it's just not intervening in a transactional way. So it's based on loops. It takes time, analyzes what the behavior is, maybe this is not right time to approach, and then as the as the work matures, as the tool matures, it starts learning the coding pattern of developer, at what time is the intervention more effective, at what time it is not effective. So it's based on these loops over time, and learning the behavior over time and improving the effectiveness of it. One thing important, that is it escalates the intervention, the effectiveness of intervention. First it's just based on IDs, then it's based on communicate Slack channel, then perhaps maybe Twitter, depending on the privacy settings, on GitHub commit, or maybe. So it keeps on escalating the interventions until the developer notices or makes a case of it that no, we're not addressing this because of this reason.
Yeah, so do you have any vulnerability detection aspect in your work, or do you consider how many vulnerabilities are present in your work? Do you do some vulnerability scanning to assess the effectiveness of interventions?
Yes, so at the moment, the work that we've reported is based more on the evidence of why there's a need for adaptive security intervention. So it's based on literature reviews of psychological literature on goal behavior of individuals, and then analyzing it based on developer-centered security literature, and then studying the existing interventions that we have. And so at the moment, we have a proof of concept, and we're working on developing on in the future on making a bit more comprehensive and more detailed view of these adaptive security interventions. But at the moment, our view is that we've taken a simple bandit security tool as an example, that how vulnerabilities are noticed by the tools and how our tool will react to it. But at the moment, we do not have an evaluation of this tool because it was a proof of concept, and the main body of work was the building the case for it, for the security community and software. Thank you.
So you have a question for Shar, so maybe you can also ask a question for Shar, the author of the third paper that was presented.
I'm here. Just somehow I cannot turn on my video anymore. So
no worries. No worries.
Yes,
we can still hear you.
Yes.
And we can still see you as well,
Yeah.
but not live.
It's not a question about why do the developer don't fix the don't
Yes.
update the libraries, right?
Yeah, I'll elaborate. Okay, so
Yes,
just a comment. I'm just looking for a comment from you, because I understand that your work is provides very strong evidence of the problem space, that developers are not fixing them and stuff like that. So I'm just looking for your comment on the solution space. That are you aware of any interventions that are helping this to mitigate this issue, because this issue has been repeatedly reported as well? And why do you think any study that you can think of, or if you know of?
Intervention part, I'm not really sure because I'm not really an expert there, but we can provide recommendations if it is useful. So recommendation will be that some of the burden should also fall on the library developers, I guess. That is the aspect that we don't really look at. Usually we blame the developers, the developer of the software, because they are the one who use the dependencies and so on. But actually, library owner themselves also not only fix the vulnerability, but also come up with a better documentation of if they use this new patch, it provides a way to use the patch reliability so that it don't affect the existing functionalities, because that is the concern that is having by the most of the developers. also maybe provide better test cases, regression test cases, and so on. So that could help, I guess.
Yes, thank you. And
Mm.
I can hear myself. I'm not sure why I can. Anyways, can you hear me?
Yes, yes.
Okay, because I can hear myself, and that's quite a disturbance for my ears. Okay.
Yes.
So my question was. Sorry, Eliana.
Yeah, no, please ask your question to Shar.
Maybe, Levin, can you mute your mic? Because I can hear myself and I cannot concentrate on the question. Hello? Okay, I still hear myself. Okay, so my question is that how are you looking at the future work of your work? Do you plan to work on the solution space and to identify how to facilitate library developers to provide such an approach?
So future work, well, there are a few directions, but I myself, I'm more interested in providing a more automated way of fixing the updating the libraries. So meaning providing automated tools to detect the vulnerabilities in the dependencies, and then kind of automatically, replace with the new version if it is possible. So that's the direction that I'm going. But I will be also interested in reading, on your future paper, maybe about how to intervene, if there is, yes.
Thank you so much. It looks interesting from that angle, so I'll contact you.
All right, all right. Thank you very much.
I just trying to give also the chance to the last speaker to answer questions because time is ticking. So we have a question to the author of the fourth paper, and so from Zhu Yang. I'm not sure, Zhu, do you want to switch on your mic to ask the question?
Yeah, I can ask the question. So in your slide, I noticed that you can your method can find some vulnerability in the nested function, which means like the main function core something, but the real thing that is vulnerable is in another function. So how much nested layers you can handle? Can you handle like a lot of layers? Will it introduce some scalability issues or something?
Okay, it's a very nice problem. In our, because we use program slicing to remove some irrelevant statements or operations. In this paper, we connect 217 program slicing standard to focus on some vulnerable statements or other memory-related operations.
Okay, so you perform program slicing and use some features to constrain the statements you want to analyze to control the experiment on a a relatively friendly, scale, right?
Yes.
Okay, I have another follow-up question. So it's about the data set. And how do you split the data set? So I noticed that you have a lot of different projects. So you train a model for each project, or you mix all the projects into one big data set, then randomly split them. Which one?
Okay, we connect our dataset from two sources. One is SARD, S-A-R-D. It's a sensitive.
Yes, I understand. I understand. I mean, you have a lot of projects, so you merge all the data from all the projects into one large data set, then randomly split them, right? But I'm thinking whether it can introduce some bias, because, for example, some vulnerability maybe has been fixed in a project A, but it's in the training data. However, the project B, which has the same vulnerability, is in the testing data. We would introduce some kind of evaluation bias.
Okay, I know, I got it. So in our dataset, we remove some similar functions or similar vulnerabilities. For example, in SARS, there are too many similar vulnerabilities in this sensitive dataset. So before we use this dataset to training our detection model, we pre-process this dataset by removing some similar functions or similar vulnerabilities. For example, because in this dataset, they will label these vulnerable samples or vulnerable functions by bad or bad 1, bad 2, or bad sample like this.
Okay. Thank you.
Okay, I just would like to give also the chance to the presenter of the 5th paper to answer questions. I actually have a question for Duo, and my question is if he can give us some insight on why did you choose to represent the source code as an image? What was the main rationale? Does an image allow you to detect better certain types of vulnerabilities, for example? So what was the reason why you chose image to encode to represent the code as an image?
Okay. Thanks for the question. And this is actually not my idea. It's a first author's idea, but I can try to explain because it actually makes sense to me when I first heard about it. So the main research question in this paper is how to efficiently convert programs like the program dependency graph into an image, because the current problem about the graph-based deep learning vulnerability detection techniques are mainly because of it's just too time-consuming and they cannot scale too well. And the reason why we use image is because technically, like right now, many tools have have to do the classification for image. So we think if we can embed all the as much information as we can about the program semantics into an image, maybe we can have a better scalability of the detection techniques.
So it was mainly scalability reason. I think there is also a follow-up from Kushal, who is mentioning that whether coding styles affect the image.
I put in the channel actually, but I can explain that part. Also, it's a good question. And before we do the embedding, like we embed all the code lines to vectors, we will first do some normalization of the code. Like we will first remove the comments, and we will map the user-defined variables and functions to symbols like var and the font. This can partly solve the coding style issue, and about other coding styles, like some programmers may squash many lines into one line like that. We have our target programs are mainly C++ programs. So I think the ending point of a code line can also help that part. And
So did you find any correlation between specific vulnerabilities where your approach is more effective?
You mean the certain pattern?
For example, when you analyze the precision and recall, for example, the performance learn detection approaches, did you find that the performance were better depending on specific types of vulnerabilities, or you didn't consider that?
Yeah, we haven't considered that. That would be a good point. Thanks.
Okay, thank you. Okay, so we have 2 minutes to go. I can see from the audience that there are some more questions for Shar. So if anyone would like to ask question to Shar.
Question for me? I'm here.
Yes, I see many questions in the chat. I can see you answer them. So there is, for example, there is a question from Bodin. So regarding the conclusion of your paper, the results highlight the importance of managing the number of dependencies.
Okay.
What is your opinion about how to do that?
Yeah. So what we find is one interesting thing that we find is the number of dependency used is pretty high in many of the projects. And also we also found even for trivial functionalities like sorting things, very simple stuff, developers tend to use like, meaning they don't want to code anything. That's I guess. But the thing is that since usually in a software project, there could be multiple developers, and they tend to work on their own. They could end up with so many diverse libraries, right? That is hard to manage. So our recommendation could be that rather than doing it this way, they could come up with a common set of dependencies that you could trust, and then share them